Hello everyone, Gradius is here, and this is the video for graphing quadratic functions in intercept form. So a quadratic function in intercept form would look something like this. Okay, we could FOIL this equation out to put it into a quadratic, look like a quadratic function. So if I FOIL, I'll get my x squared, which is that symbol. We look for that x squared to make sure that it's quadratic. So I'll get x squared, I'll get 1x, I'll get 3x, and then I'll get 3 when I FOIL. Okay, so, and then from here I would have x squared plus 4x plus 3. So this is a quadratic function. What I want to do is I want to be able to graph either this or this, but I'm going to need it to be in this form in order to graph it. Okay, so step one would be if you had an equation that looked like this one right here, you would have to factor it first to make it look like this one right here. Okay, step two, and then you want to find the x-intercepts. Okay, so if we look at a graph, the x-intercepts, there's probably going to be 2, likely, possibly 1, possibly 0. But our x-intercepts are when the graph crosses the x-axis, so that is also when y is equal to 0. Okay, so we would solve an equation when y is equal to 0. We'll show an example of that. I then need to find the x value of my vertex. So my vertex is here. I need to figure out what the x value is. And then once I find the x value, I plug it in to figure out what my y value is. Okay, so get down these steps real quick and let's go for an example of this particular equation right here. So first, step one says factor if necessary. I already have a factored quadratic function. So I already have it in intercept form where I can easily find my intercepts now. So now I find the x-intercepts. So the x-intercepts are when my y is 0. That's when this parabola is going to cross the x-axis. So what I can do is I can plug in 0 for y. Oops, sorry. Computer's spazzing out. I can plug in 0 for y. Okay, I don't know why it's doing that. I'm sorry, guys. So if I plug in 0 for y, then I can actually solve this equation. So we have to know how to solve these equations first, quadratic equations. If you don't know how to do that, then you need to go back and watch that video. Okay, so I can solve this equation by setting it up as 2 separate equations, because I know if the values inside these parentheses equal 0, then when I multiply by whatever is inside here, the whole equation would equal 0. Same thing here. If the value inside this parentheses set equals 0, because this is just this set times this set. If this equals 0, then that means no matter what number this is, it's going to equal 0. So I set up my 2 equations, x plus 3 equals 0. This is going to give me one of my x-intercepts. X plus 1 equals 0. Okay, this will give me my other set of intercepts, my other intercept. So I can solve. I will get, if I minus 3 on both sides, I'll get x equals -3. And I will subtract 1 on both sides. I'll get x equals -1. So those are the 2 x-intercepts for this graph. -3, -1. Okay, those are 2 points on this parabola. So now I just did step 2. Step 3, find x value of the vertex halfway between the 2 intercepts. So my vertex, the x value of my vertex is going to be halfway between this point and this point. Okay, so I want to figure out what's the halfway point. 2 ways I can do that. I can add them up. So I can do -3 plus -1 and divide by 2. So it's going to give me -4, because this is just finding the average between the 2. So to find the average, you add the 2 values, you divide it by 2, and that's going to tell you what the average is, which is also the halfway point. So I get -4 divided by 2, which is -2. So my x value is -2. Also, you can just look at the graph, and a lot of you can see that -2 is halfway in between -3 and -1. But this helps when we have bigger numbers or more difficult values to work with. Okay, so find the x value of the vertex. So I know my vertex, the x value of my vertex is going to have an x value of -2. So now what I need to do is I need to figure out what my y value is. Okay. In order to find my y value, I plug in the x value for the vertex and solve for y. So I can plug in -2 into this original function and then solve my equation for y. So I would have y equals -2 plus 3 and times -2 plus 1. And now I would just simplify this equation to figure out what my y is. Well, -2 plus 3 is 1. And -2 plus 1 is -1. So 1 times -1 is -1. Okay, so my y for my vertex is -1. So there's my vertex, -2, -1. Okay, and there's my parabola. All right, now let's look at another one. Same exact thing. So what you would do is you would first factor if necessary. I don't need a factor, it's already in intercept form. So then I find my x-intercepts first. So if I plug in 0, I can solve an equation for when x is 0. So for y, when y is 0. So I'll have 2x minus 4 equals 0. So that's two separate equations. And I'll have x plus 4 equals 0. Sorry, this is slow. My pen's a little funky right now. All right, so now I would solve my equations for x. So if I add 4 to both sides here, I'll get 2x equals 4. And for the sake of time, I'm going to skip the next step and just say that x equals 2. Okay, and then for this one, x equals -4. So I have my intercepts. So I know x equals 2 and x equals -4. So now I want to find the halfway point in between these. 1, 2, 3, 1, 2, 3. My halfway point is -1. I can figure that out just by counting. I also could have added these and divided by 2. If I had done that, I would have had -4 plus 2 is -2 divided by 2 is -1. So I know my vertex is at x is -1. So now I just got to figure out what my y is. So in order to do that, I plug in -1 into my original equation, and I can figure out what my y value is. Okay? So this is the first set of parentheses times -1 plus 4. And now I would simplify both sets of parentheses, and we'll do that just quickly. We got 3. And here, 2 times -1 is -2 minus 4 is -6. Okay? So -6 times 3 is -18. Okay? And then, so that means my vertex is at -1, -18. Obviously, this one's going to be a little bit difficult to graph here. That means my vertex is like way down here. And there's my parabola. Okay? Let's look at just one more example real quick. And so now, if we have an equation that's in actual standard form, so this looks like a normal quadratic function, what we want to do is we want to factor it first, if we can. Okay, so we've got to be able to factor this. And then we'll put it into that intercept form. So if I wanted to factor this, what I would do is I want to make sure I find my values, my multiples of 8 that add up to 6. This one's pretty easy to factor. So if you don't know how to factor, again, go watch that video. You're expected to know how to do that. So this one I'll get y equals, that y equals doesn't go anyway. And this one, when you factor it out, you will get x plus 4, x plus 2. Because 2 times 4 is 8, and then 2 plus 4 is 6. And then again, from here, I would find my intercepts. So x equals -4, and x equals -2. So now that I have my intercepts, -4, -2, find my halfway point, which would be -3. I can then plug in for my vertex. I can plug in, this is my vertex here, -3 into my formula. Into my original function, I'm sorry. I can either plug it in here or I can plug it in here. It doesn't matter because this is the same as this. So I can plug my -3 into this if I'd rather work with this equation, or I can plug it in here if I'd rather work with this equation. I'm going to plug it into here just because I can. So I'll have -3 squared plus 6 times -3 plus 8. Okay, that's going to give me +9 minus 18 plus 8, which is going to give me -1. So there's my vertex at -1, -3, -1, and there is my parabola. Okay, so that's all, folks. That's all I got for you. If your vertex isn't a perfect point, that's okay. Okay, so when you find the average, if you get a half point or something along those lines, there's nothing wrong with that. That's perfectly fine. You would still graph as normal. Quick math joke for you guys. What do you get when you cross an algebra class with the prom? So what do you get when you cross an algebra class with the prom? And you get the quadratic formal. Quadratic formal. Boom. Awesome. Okay. Anyways, you guys, hope you guys like that, and hope this video helped. If you guys have any questions, let me know, and good luck.